x2 and y2 giving 2xy. And this is the mechanism. This is fast equilibrium. This is the slow step. And this is also fast step. This is the overall reaction. What is the overall order of the reaction? So first you need to figure out what is the rate law. Got it?
Yes, sir.
And then you need to work on it. So Ibrahim, what should be the answer? Yogita, Jasleen.
Okay, Mike. So it can't be 0. Is it?
Can't be, yeah, 0. It is not 0. Yeah, that is not the
It's
answer.
not 0. So I mean the rate determining step is equation 2. That's okay.
Yes.
That's true. That's the RDS. I mean, I'm guessing it's 2. No, wait. Oh.
Got it? So I will use this because as my reference for deciding the rate law. So based on that, I've written this. Ibrahim, Jasleen, Yogita, is it
Yes.
clear?
So the orders of both of them is 1. So 1 plus 1 will have 2. Yeah?
But there is a problem. Yeah, that is true. But there is a bit of a problem.
Why 2?
This is the problem. Got it?
Yes. Yeah. Yeah.
So it can be, its concentration can be derived from the first equation. So we will follow this. We are following this, but the concentration is of X can be written from the first equation. So for the first equation, let's say this is K1 and K2, or this is the equilibrium. So let it assume to be like this. K dash with the equilibrium constant. So how you write the equilibrium constant, expression for the equilibrium constant, tell me? Hmm. In class 11th, you might have seen, if you are forgot, I will. Got it? Is it clear? So what is the equilibrium constant? How you write it? Justine, tell me. Yes, Justine, you are correct. So what? How you derived it? So equilibrium constant you might have seen in class 11. Concentration of products, Yogita, each raised to the power its stoichiometric coefficient x square by x2. So from this, I can figure out the concentration of x. Got it? And I will put it here. Ibrahim, are you getting my point or not? Yogita,
Yes, sir.
are you?
Yes, sir.
Okay. So this is half and y2. So this is overall, it is. I hope this is clear to you. Okay.
Yes, sir.
So be careful of this. If you have it in the equation, express it in terms of reactants and get the overall rate law equation. And with that, you need to find, this is okay because you have x2 and y2, x2 and y2. So this is okay. The final expression which I have written, but the initial expression need to be changed. With that, you cannot tell what is the overall. Right, Yogita, is it clear? So do ask me if there is any problem. Next is, let's move on to the next question. So domination of acetone in acidic medium. Is represented by the following equation. But during the domination, acetone is taken. And H plus is the catalyst. And as this is acetone with one bromine attached, and these are the products. So this is, and initial concentrations are given. So this method, the above method, was with the help of the mechanism, and this is initial rate method. So in this, you are given with acetone, Br2, H plus, and the rate. Concentration are in mole per liter. So what is the overall order of the reaction? You can find the overall order of the reaction. This is not the mechanism which is given to us. Initial rate method, as I told you, you carry out the same reaction with different rates. Got it? So when you carry it out with different rates, you measure the initial rates and you compare that how the reactants are affecting, the concentration are affecting the overall rate of the reaction. So just tell me what is the overall rate one. Just also tell me whether it is going to be the complex reaction or elementary reaction. Is it clear or not? The question, you have to tell me the rate law, order, and you have to tell me whether it is a complex or an elementary reaction. Ibrahim, Jasleen. So what is going to be the answer? Yeah, Ibrahim, are you getting the answer or not? Tell me, Yobita. This is quite simple, I told you. Just tell me what are you doing? Yeah, Ibrahim,
So
tell
for
me
that,
what.
for the first one, we can find the K, the reaction constants. Then we can find the reaction constants for all four cases, and then I think
Yeah, you
C.
need to, but you need to do it quickly because this is from the NEET. Okay, so you will be having less time, so little bit quickly you
Mhm.
can do. Okay, I can write rate equal to.
But I mean, won't the because I don't think the concentration of Br2 will matter in here because even if
Exactly.
we increase the concentration of Br2, the rate is the same, yeah.
Yes, exactly. So look here and look here. The rate is same, so it is not affecting
Yeah.
exactly.
So I mean, it will be a
Now,
complex reaction
yeah, it
that
is a complex reaction exactly. And now you need to look for this, right? Or take a set of data where everything else is same and the other things are changing. Let it be x and y. Right? BR2 we already figured out that it is going to be 0. Okay, it is not going to affect. So the power, the order is 0 with respect to BR2, but not the overall order. And then you take x plus, that is should be y. So what should be the value of x and y? For h plus, you can, for to study h plus, you can take these two data. Is it clear or not? So what should be the order with respect to h plus? Hmm. Justine, are you getting anything? Order with respect to h plus. Ibrahim, Yovita, what should be the y? Any idea about y? So divide these two equations, put the value. This is same, this is not changing, only this is changing. and you have made the H plus concentration 2 times. And how much is the concentration change? Roughly how much it has changed? Are we getting any answer? This is also, this I think is, so H plus concentration is 0.05 and 0.01 to the power x. You can see to the power y. The power of H plus is y, and that is equal to 5.7 into 10 to the power. This is the rate. 1.2 into 10 to the power minus 4. 5.7 into 10 to the power minus 5. So this is going to be, this is zero point 0.1, not 0.10. So this is 2 times. Okay. And this is how much? So 5.7 approximately it is equal to, actually it is not equal to exactly half, but approximately when you near it about, because you need to take the integer. Okay. So it is 1 by 2. So y should be taken equal to 1. Ibrahim, Jesslyn, Yogita, are you getting? Take it as 6. And this is as 12. So 1 by 2. Got it?
Yes,
To
sir.
the power 1, y is equal to, because sometimes you are not getting the exact integer, so you can take the approximation little bit, and with that you can do. So order with respect to H plus is 1, X is also 1, overall order is 2, and this is a complex reaction. Here, let's do one more question. This is about the integrated rate law, which we covered in the last class. A lot of questions are being asked in the integrated rate law part. So let me ask you the question, the half-life of a zero order reaction. This is also from the PYQ. Having 0.02 molar initial concentration is 100 seconds. So what is the rate constant? This is a zero order reaction. So you need to have the integrated rate law for the zero order reaction in your mind. Are you getting it or not? So what should be the answer? I will give you the options. Yeah, Jasleen, Marwa, tell me. Ibrahim, Yovita, what is the integrated rate law for zero order reaction? First, tell me that, whether you remember it or not. Okay. So, what was the integrated rate law? That gives you that how in that it gives you the concentration as a function of time. So, tell me
The integrated rate law will have as
for
K
zero
A
order.
naught minus A by T, yeah?
Yeah, it is equal to the concentration at any time is equal to the initial concentration. Got it? Now you will put the values. K is being asked for the reaction. This is the initial concentration, and the final concentration will be this one. Is it clear or not? Now we can get the value of K very easy. Yes, Justine, it is clear. You are right actually. Yogita, you need to remember this
Sir, I
integrated
have
rate
sent the
law.
answer.
Pardon?
Sir, I have sent the answer to the in chat box.
Yeah. Who asked me if you have any doubts, right? Okay. Yeah, you have posted the answer. Good. Yeah, correct. So let me move on to the next question. So you are not going to derive, just remember it for zero order at least. Zero and first, they are the most important. These two. So this is for the first order reaction. The units of K, you can see if it is not given, it is given, it is first order. If it is not given, you should not bother. Sometimes, most of the time, it is not given. So you can find it out. Keep an eye on this, right? So how much time do I need for this much reaction? in seconds. We need to check. So what is going to be the answer? Very easy question. The data is also very small. If you can figure it out what it is trying to ask, you can very easily do it. So what is the time required to change 40 grams to 10 grams? Yeah, Ibrahim, tell me, how should we do it? Jovita, what answer you are getting? This is the first order reaction. Yes. What about Ibrahim and Jesse? What answer are you getting? So K is and you know KT. Log of initial by final. Very easy question. The data is very good. It is getting cancelled very easily. Yeah, Ibrahim. So this will get cancelled. Okay. And the time is 10 to the power 3 into log 4. Log 4 is 2, log 2. Log 2 is 0.3. Got it? So it is going to be 602 seconds. So I hope this is clear. Very easy question. Okay, and the data they have given it in a very nice way. Normally we don't have to waste time on the data, right? Of solving, because sometimes there are questions where the numerical part is very tricky. You need to divide, multiply, that division, multiplication, and all. That takes a lot of time. So this is not the problem in this question. And very easy question. Next, so these are all from NEET. this is also about the integrated rate law only. For the first order reaction. So at 10 seconds, you are having this rate. And definitely after certain time, the rate is going to drop. So at 20 seconds, the rate has decreased. Okay, you can see the rate from 0.04, it has come down to 0.03. So what you need to do, you need to tell me what is the half-life period. So what should be the half-life period? After 10 seconds, the rate is given. And after 20 seconds, the rate is given. How you are going to do it? Yeah, Ibrahim, tell me.
So first, find out K. Yeah.
First, find out the K. Yes. Yeah, Jaslin, I hope you are able to understand. Is there any concept, just Ibrahim, just for a second. Jaslin, is there anything which you have not understood?
No,
In
sir,
the
I got disconnected. So
yeah,
the
okay.
previous question and
Yeah, previous question. Should I explain it again? Okay,
yes,
this
sir.
is just, I will take 1 second, Ibrahim, and we will start the discussion again. So rate constant is given, K is given, and this is the mass given, mass and concentration, they are directly related. So you can put it directly in the integrated rate. Got it?
Yes, sir.
KT equal to, this is the integrated rate law for the first order reaction. Put the value of K over here, time you can find out. Okay, this will 2.303 will get cancelled, and the log term is log 4, so easily you can figure it out, right? So I hope this is clear, Jaslin.
Yes, sir.
Okay. Yeah, Ibrahim, how you got this answer? Now tell me.
Yes, sir. We find out K.
Yeah, how you found out
So
K?
2.303 by T2 minus T1 log A1 by A2. We can do that.
Hmm. How you find it out? Yeah,
What's that?
tell me. Yeah, what is the formula you are applying?
Sir, 2.303 by
Yes.
T1 minus T2 log A1 by A2.
Yes.
Or we can also use this one, yeah, integrated rate law. Log A naught by A is equal to KT.
Log of A1 by
Yeah, is equal to KT. We can use that one.
got it.
Yeah, and then we can solve.
Yeah, and how you are going to get the concentrations? These are the rates. Ratio of the concentration, how you are going to get?
Oh, the concentrations. Oh, okay, yeah. Rate is directly proportional to concentration. Yeah,
Yes,
first order.
exactly. Yeah.
So
So
rate 1 by
you
rate.
can directly put the rates, you will get the ratio of the concentrations. Exactly. Right.
Yeah.
And from that we got the K. Okay. This is Jyotita,
I got is
yeah, how much K?
0.0287 per second.
Jyotita, how much you have done this? Log A1 is 0. So 4 by 3. Got it. So I will remove the decimals. Got it. So log 4 is 0.6. Roughly I am taking 0.3010 into 2. And this is 0.4771, so 0.48. Got it? Yeah. So Ibrahim, how much you got the K value of K?
I got it as 0.0287 per second.
Right, this K. And now what you are going to do? You are going to figure out
T half is 0.0693 by K. So,
yeah, 0.0693 by K. Got it.
yeah. So, we can
So is it clear, Jyotita?
yes.
And what Ibrahim is telling? Yes, correct. Jaslin, is it clear?
Yes, sir.
So we are going to do this, and once we have the K half-life, we can figure it out from 0.693 by K. Let's move to the other PYQ. This is very easy. And if the initial concentration is doubled, half-life is not affected. So what is the order of the reaction? This is direct question. Half-life remains same. Very, very easy. Direct question. So what answer are we getting? Jaslin, Jovita, half-life remains same even with more concentration. Ibrahim, you have to recheck little bit. Actually, you have given answer in a hurry. Just recheck it once more. Jovita and Jaslin, just check it once again. Yeah, tell me quickly. This is very easy, Ibrahim. What mistake you did? Jovita, Jaslin,
So first order.
first order. Yes, correct. First order, the half-life remains constant. Got it? It is in so concentration. Actually, initial concentration is doubled. Uh, Ibrahim, what mistake you did? Have you realized?
Yes, sir. Yes, sir. Yes, sir. I did it wrong. I thought it was half-life becomes double.
Actually, yeah. What you thought actually, uh, though you know it, I'm quite sure that if the initial concentration is doubled, the rate will get doubled. Okay, that is first order.
Mm-hmm.
And the rate doesn't change mean zero order. But this is not the rate given to you. This is the half-life given. Okay. So half-life,
Mm-hmm.
as I told you, it is inversely related, and this is actually not changing. Means this dependence should not be there because half-life is same. So you should make it 0 and equal to 1. Got it? Clear? Let's move on to the next question. Okay, so you need to tell me whether both are true, the first is true or the second reason is true. And is if the both are true, whether the reason is explaining the assertion correctly or not. So reactions with molecularity more than 3. Okay. Actually, we are talking about that's why we are talking about this molecularity. Such reactions are not very common. This is correct. Okay. And this is a very common question. It is because how this collision is going to be very problematic, right? More than 3 molecules or 4 molecules at a time, it is very difficult. So this is correct, and the reason is also explaining it correctly, right? So I hope it is clear to everyone.